Okay, I'm recording. I'm going to do a module called tread depth, measuring tread depth, okay? The tread depth of tires must be regularly checked. This enables you to determine whether the tire needs replacing. If a tire has little tread, it will have little grip on the wet road. There are two ways of checking the tread depth: wear indicators and a tread depth gauge, okay? Does a tire with little tread have grip in wet weather? No, the tire has little grip. That's my guess. I am right. Next, where can you find a wear indicator? On the rim? No. On the inside of the tire? No. In the main grooves? On the tread? I'm going to say in the grooves. See, these, if you can see my pointer, those are my wear indicators. So those are in the main grooves, I would say. I'm going to go with main grooves. Let's see if I'm right. I'm good in the main grooves. All right. These are cross sections of a tire. Click on the wear indicators, which indicates the tire has just reached the point of needing replacing. Well, that's where, let's see. Where's my indicators? I'm looking for my indicators. Oh, right here. I'm going to say this one. I'm going to say this one. I don't know. It just says one. I wonder if I'd have clicked on there. But right there. Click on the wear indicator that indicates the tire has needed replacing for some time. This tire has needed replacing for some time. Right here. I'm good with that one. When does the wear indicator show that the tire requires replacement? When the indicator can no longer be seen. When the indicator is below the level of the tread. Not below it. When the indicator is level with the tread surface. I say that one. Level. Yep. When it's level with the surface. Okay, here's a tread depth gauge. Let's see. Turn the tire by dragging it. How do we do this? I think this is what I need to put you on my head. Hold on. Maybe let's see if you can see. Maybe you can see. I wonder if I could space this up a little bit. Maybe I could space it up. Let's see. Y'all don't know what I'm doing, but I'm doing something. You'll watch me. Oh, drag the tire. I've never seen this done like this. What is this doing? A tread depth gauge can be used to measure the depth of the tire tread. For safety reasons, it's best to have the tread depth of at least 2 millimeters. We want at least 2 millimeters. I guess this is in millimeters. So we want at least 2 millimeters. 2 millimeters or less means it needs to be replaced. Okay? The tire chart shows which grooves you should measure. The tire chart does. Where's the chart? I guess this is the chart. So let's see. Can we drag the gauge up? We got to slide it over. Hold on. How do I slide it over? Oh, I saw something. Something slid over. This is what Ramon was telling me. So we're not in the groove. So How do I get to a groove? Is that in a groove? Turn the tire by dragging it. Oh, maybe I have to turn it. Okay. Right there. Is that what it wants me to do? What is the minimum tread depth for safe driving? Well, we know that's, what they say, 2 millimeters? 2 millimeters. So that's the minimum. Now let's see. Click on the tire chart to the left of the screen. Oh, there it is. Okay. We did that. Let's see next. Hopefully you can see all this. This is a 185 ADR 1495S tire. Check the grooves, which you must measure. Click the grooves, which you must measure. So, what does this chart say? 185? How do we get this chart? Well, I clicked on that one that had 185 on it. Okay. This is a 185 AD 14-inch tire. Click on the grooves which you must measure. All right, don't know what they're asking me. 1 of 3. So these grooves. I guess that was one. I get it, Ramon, I get it. All right, so this one. This one. This one. This one. These 3 right here. These 3. I don't know what this chart has to do with anything. I don't get it. 1. What does the chart mean? Oh. The chart, is it saying this one, and this one? Oh, let's see. Is that what that chart's saying? This one? No. Why is it lined up with that? I don't get. What does that mean? All right, so here's the ones it wants, which It's any tread on a tire is that low. We're gonna tell them they need it. So it wants this one, and this one. Those three center ones. Hopefully you can see that. This one, and this one. Okay? What is the tread depth? Let's see. I think I checked it, didn't I? I gotta slide it over. What'd I do? I moved it. I don't know, it's kind of stupid, isn't it? Is it 1.3 millimeter maybe? Well, what's it? I don't know. I can't get the gauge into where I want it. Right? Don't I want to get it to that tread to there? How do I move the gauge? Oh, there it is. There it is. 3 millimeter. 3 millimeter. Check. Boom. 3 millimeter. I got it to slide. I couldn't get it to slide earlier. I got it to slide. So 3 millimeter. Does this tire need replacing? No. We would tell them it's getting there. And this is at 205 60R14. Measure the grooves with the tread depth gauge. One and a half. Let's put 1.5. I don't know why I can't move it. Check. Says good. Does this tire need replacing? Sure. Absolutely. I'm hoping you can see me. Okay. You finished the lesson. Beautiful. Do I need to go to the quiz? Let me check the quiz out. Let's try it. Let's try the quiz. Let's give this a shot. All right. Let's see. Tread depth quiz. Measuring tread depth quiz. Some people did really well with the quiz. Who did well? Jeremiah rocked it. Logan did. Ramon did. All right. I thought didn't Ramon say he had a hard time with it? Somebody said they had a hard time with it. Tread depth quiz. What can you use to check the tread depth? Wear indicator. Tread depth gauge. Looks good to me. How'd they do so well on it? When I'm going to have troubles. These are the sections are which wear indicators suggested it's time to replace a tire. Well, I know this one. The bottom one. What? Which wear indicator? Oh. Huh? Which wear indicator? Oh, there's no wear indicator on this one, is there? This one has a wear indicator. That one doesn't have a wear indicator. Got it. What is the tread depth of this tire? Oh, that's 3 millimeter. Which grooves will you measure to check the tread? Well, 2, 3, and 4. 2, 3, 4. Boom. What does a wear indicator show that a tire requires? When does it show? When it is level with the tread surface. Boom. You finished. Cool. All right. Go knock that out and get that done. All right. Let's see. Let's go. Let's go. What was the other? What was the one someone asked me about? Someone asked me about one on wheel balancing. Wheel balancing machine. Let's try that. Wheel balancing machine. Start module. Let's go. This could be a confusing one. It'd be easier to see this on a. Oh, let me put you all on a stand here. Let's see, maybe I can get you centered too. Let's see. Can I get you closer? All right, I'll try that. A wheel balancing machine is used to correct wheel imbalance. When mounting a wheel to the machine, it's important to perfectly center the wheel on the shaft. Otherwise, the wheel will oscillate when it's spun on the machine. Wheel mounting is accomplished in one of three ways: using the bolt holes through the center hole in the wheel, using the bolts and the center hole, the wheel balancer, through the center hole in the wheel. That's the way we do it. I've never done one with the bolts. I didn't even know you could do it with the bolts. I'll have to look and see if that's possible. The wheel balancer measuring arms are used to measure the following: diameter of the wheel, width of the wheel, distance from the wheel to the reference point on the wheel balancing machine. What do you use to correct imbalance in a wheel? What do you use? All right. See, my screen went blank. Oh, you can still see, I hope. What do you use to correct imbalance in a wheel? A wheel balance machine. That's what we use. We're going to use a wheel balance machine. Beautiful. Okay, that's right. Next. It is important to center the wheel on the wheel balancing machine. Oh, is it important? Yeah. I hear my door open. Is it important to center the wheel? Yes. It's got to be perfectly centered. Perfectly centered. Correct. What points can you use to center the wheel? The central hole in the wheel? The bolt holes? I think they said you can use that. I've never done that. Not the valve, not the spokes. I think we're good. All right, yep, it says I'm good. What information does the machine require in order to balance the wheel? The diameter of the wheel, yeah, it needs to know that. The distance from the wheel to the reference point on the wheel balancing machine. What bell is that? Halfway point?
Yeah.
Okay, needs to know the width of the wheel. The distance from the wheel to the reference point on the balance machine, I'm going to say yes. Doesn't need to know the weight of the wheel. Never heard of that. We're good. We are good. Yeah. All right. I didn't miss anything, right? Let's go back. Did I miss anything? Nope, I didn't. Okay. In order for the machine to accurately determine the wheel imbalance, several measurements need to be made prior to spinning the wheel for the first time. Begin by positioning the measuring arms against the inside top of the wheel edge. The machine will register the wheel's dimensions. In practice, after the measurements are set, always be sure to lower the protective hood before you spin the wheel. Click on the measuring arms. All right, where are the measuring arms? Oh boy. Where are the measuring arms? I can't see on that machine. Measuring arms, where are you? You have found one of the components. Measuring arms. I don't see them. One on the inside, one that comes down on the outside. Some wheel balance machines only have one measuring arm. All right, so cool. Here you see a cross section of the wheel. There's your tread. There's the, all right. To the left, we're going to measure the rim on both sides, right? To the left and right of the wheel, you see the measuring arms. It's over here and there. Drag the measuring arms at the top against the inside. All right, so I'm going to have to hold my camera again. Oh, hopefully I'm still recording my stuff. Just 20 minutes, I think I am. So, this will go against the rim. This will go against the rim. Okay. Yeah, right. I'm checking where the weights. You always put the arms where the weights go, okay? That's where you put it. On the screen, you can see the dimensions of the wheel. What is the width of the wheel? The width, oh, I can't read that. The width, what is that? It's a 6.00. I think it's a 6.00. Yeah, but my eyes aren't good enough to read that. 6-inch rim width. What is the diameter? Diameter. Is that 130? Wait a minute. Hold on. Oh, it wants to know rims? Okay. 15.0. It's a 15-inch rim. The diameter, 15-inch. I see it. What is the distance from the wheel to reference point? That'd be 131. That's 131. There we go. Okay. Click on the protective hood. That's this right here. Boom. It's now safe to balance the wheel. Well, that's how you get it to go. Click on the start button. Boom. Start. Wheel spinning. Boom. Oh, it says now you can add the correct amount of weights. Let's see. So we got to go to the next one. All right. So after the test, the balancing machine knows where the weight needs to be placed. When both arrows are gray on one side, you have to place the weight here at the top of the wheel. Clamped wheel weights are used for steel wheels. Adhesive wheel weights are used for alloy wheels. Clamped wheel weights will damage the alloy wheels. Click the start button to practice. So, well, they're right and they're wrong, just to a degree. Okay, so the wheel's spinning. Good, we did it. Let's go next. Click on the wheel balancer display where it shows how much weight needs to be added to the wheel. 1/2 ounce right there and 2.5 ounces. 1/2 ounce on this side, 2.5 on that side. Click on the wheel balancer display. Right. Those are the two. 1.5 on one side, 2.5 on the other. The arrow above and below the reset button enables you to rotate the tire. So I guess when there's nothing there, rotate the wheel until both arrows on the left side of the wheel are gray. Okay, I guess right there. What? Left side of the wheel are gray. What? Aren't they both gray? Oh. Okay, I have no idea what they want me to do. That's why you're having a hard time. See, right now, that should be, they're both gray. What do you mean it's not right? Rotate the wheel until both arrows on the left side of the wheel. Isn't this the wheel? Isn't that this? Aren't those gray? Well, let me try the right side. Let's see what that is. No, that's not right. The left side. Left side. Huh. Okay. Oh. Left side. Okay, what did I do differently? I don't know what I did differently, but I got it. What the heck? When both arrows on the left side turn right, where would you attempt to place the weight? Well, it would be up at the top. Right there. Place the indicated weight in the correct position. So it wants 1.5. Which one of those is 1.5? This? Is that a 1.5? Oh, I guess I did. The wheel is not correctly balanced. Oh, hold on. Isn't that one right there? Is that one? What's 1.5? What is 1.5? Hold on. Are the weights, you must place the weights all the way at the top. Have you placed weights on both sides of the wheel? No, I haven't. Okay, so let's go. The other side. Let's do the other side. Oh, did I not have the one on the one? Wow. And is that not a 1.5? I don't know. I don't know. All right, I've lost my mind. All right, on a real wheel, we'll know how to do it. If you all can do that, you all do it. All right, so I'm gonna take this off your plate. Horrible, too crazy to understand, and it's a waste of time. All right, I'll take that one off your plate. I'm gonna tell you don't need to do that one. But you would put it at the top. I don't know. They're not explaining to me what all this means. I mean, is that a 1/2 ounce? Is that a 1 ounce? Is that 1.5, 2, 2.5, 3? I don't know. I don't know what those are. It doesn't make sense, and I can't tell. One time it said I was right. One time I said I was wrong. Pretty weird. All right, so let's get out of this one. I'm gonna take it off your plate. If you all can figure it out, please do. If you want to play with it, then come teach me. As I say, it's pretty stupid. What a stupid one. All right. Do I have any more time on here? I do. I got more. Let's go to the next one. Again, wheel balancing. I'm going to take off your chart. Steering system. Let's do that. Steering system, an important one. Should be. I hope this is not a bad module, like I'd say the other one is. Okay. All right. The vehicle's course of direction is controlled by means of the steering system. It enables the driver to transfer the movements of the steering wheel to the wheels, causing the vehicle to change direction. The steering system consists of steering wheel, steering shaft, steering gear, tie rod ends. Yep, that's it. Okay, you can turn the steering wheel, click on the following part: steering gear. Steering gear is like the rack. That's the rack and pinion, okay? Steering shaft is the shaft that connects the steering wheel to the rack, okay? Got it. Get it, got it, good. All right, the next one. What is the function of the steering system? Determining the direction of the vehicle, dampening the vibrations. It determines the direction of the vehicle. That's what the steering system does. It changes the direction of the car. All right, cool. All right, now here's the two different ones. There's a top one is a rack and pinion. The bottom one is a parallelogram. Parallelogram steering. All right, that's what the bottom one is, a parallelogram. I've got you, I think, assignments in both of them. Okay, you can turn the steering wheel. Let's turn the wheel. Whoop, whoop, look at that. Like windshield wipers. Whoop, whoop, right? Turning the wheel. All right, pretty cool. That's how they work, right? The bottom one, this is the steering gear. It's moving this pitman arm, which moves this attached to the center link, and then there's an idler arm over here, and then there's tie rod ends. Right? We change the toe by adjusting tie rod ends. This one is, there's a pinion, rack and pinion. There's a rack in there and a pinion gear. And it just turns and moves the rack one way or the other. This one has bellows boots. These bellows boots protect it. And there are tie rod ends on the end. And when you adjust the tie rod ends, adjust toe. The wheels in and out, okay? All right? So what's the main characteristics of the rack and pinion steering system? The steering gear operates the tie rod ends via system of rods and linkage. No, rods and linkage is the parallelogram. It's located between the right and left tie rod ends. Yes, that's the rack right there, between the tie rod ends. Boom. Boom. It's like that. Okay, next one. What's the main characteristics of a parallelogram steering? Well, that one has linkages, rods and linkages, right? That's got, this one is what my man's got right next to me in that 69 Mustang or 70 Mustang. He's got a parallelogram steering. He's got an idle arm, pitman arm, a steering gear assembly, right? So that one's got rods and linkage. Okay, click on the correct steering system. Rack and pinion. Boom. Parallelogram. Boom. Find the components of the parallelogram system. Steering gear. Boom. Steering rod. Center link. It's more named a drag link or a center link. And these are my tie rod ends. There and there. Okay. Click on which vehicles have a parallel steering arrangement. Old cars, all old cars did. Newer cars don't. There are two types of steering systems: rack and pinion parallel. In passenger cars and light delivery vehicles, the steering gear is mounted between this is called a rack and pinion. In heavy industrial vehicles with steering gear operates. So they're saying heavy duty. They're saying, let's see if that's what they're saying. Oh, come on, don't do that box. Get that box out of here. They're saying trucks and buses, not in cars. Light commercial vehicles. Let's try this. They say just trucks and buses. Okay, but older cars had them, and older light commercial vehicles had them. But today's cars, it's just trucks and buses. Okay. Find the components of the rack and pinion steering gear, and tie rod end. They want you to do that one. Boom. All right. Which vehicles have rack and pinion steering? Cars. And light commercial vehicles. Boom. When is the power steering necessary? Whenever the weight of the vehicle or weight on the turning wheels becomes too great. Whenever the weight on the non-turning wheels becomes too great, only when the What? When the weight of the turning wheel becomes too great, the steering becomes heavy. Additional power is needed, okay? So whenever turning wheels becomes too great, boom, and it gives you the answer up top of what they want. Click on the components: electric power steering, electric motor up here, and the steering gear down here. That's our rack. Boom. Click on the components of hydraulic steering, driven by the engine. Hydraulic pump gears, that's your pump, mounted to your engine, driven by the belt, and the steering gears down here. Okay, we got bellows boots, we got tie rod ends, we got power steering hoses. One of them is a high pressure, one of them is a low pressure return line. Click on the components of hydraulic steering, driven by the electric motor. That's an electric motor driving the fluid. Hydraulic pump right here, boom. And steering gear is our rack and pinion. Which system is used most often on modern vehicles? I'm going to say electric power steering. Most cars today have electric power steering. I've seen service writers call up customer and say, hey, you need a power steering flush. And then the customer goes, what? I thought I had electric power steering. What? Oops, sorry, wrong car. I was talking about another customer. I've seen that happen. Some service writers just sell jobs. So steering system I want you to do, that was good. That was easy. Let me see if I can get one more in. Let's do one more. Let's try one more. If I got enough room on my card, I'm gonna try one more. Let me look. Let's see. We got 30. Yeah, I got 37 minutes on the battery and plenty of room on my card. So we can do one more. Let's do one more. One I find important. I should do the one on tires. Let's do independent suspension. Okay, independent suspension. Let's go. Independent is just what it sounds like. Each wheel works independent of each other. All right, dependent, the left side and right side are together. See, this wheel bounces up and down and doesn't affect that wheel. That one goes up and down, doesn't affect this one. A dependent would be a bar across them. And when one goes up and down, the other one goes up and down. Which type of suspension is illustrated? Well, that is independent. Okay, this one works independent of that one. What is the construction characteristics of independent suspension? The wheels are connected by a rigid axle. No, that would be a dependent one. The wheels are not connected to each other. The wheels are connected to a torsion axle. Well, they're not connected to each other. Okay, they're separate. This one's separate from the side, right? What are the characteristics of independent suspension? Compact design. Not much installation space is required. Better directional and cornering stability, I'd say yes. Better steering feel. Sure, I would say that. Compact design, not much. Maybe all of them. Let's see. I'm not sure about the top one. Yep, all of them. Where is independent suspension often used? On commercial vehicles, passenger. Most often, passenger vehicles. Commercial might have more of a dependent. It's more heavy, rigid, heavier duty maybe. Okay, so this one, look, that one going up and down, look, doesn't affect that side. It's totally separate. This one doesn't affect that one. Okay, what is true concerning independence? The movement of one wheel is partly transferred to the other wheel. No! The movement of one wheel has no influence on the other wheel of the axle. Yes. The movement of one wheel directly influences. So we got that right. We know that. Beautiful. Okay. Which wheel setting changes for the wheel that remains on level ground? Which wheel setting? No setting change. Nothing changes when that one changes. Does it? Could affect. No setting. Right? The other one stays the same. Which wheel setting changes the most in both wheels when the vehicle drives over a speed bump? Huh. Well, I'm watching it. If you watch this, camber changes a little bit, doesn't it? Camber. Can you see it? Look at that line. That's saying that tire leans in a little bit. So camber is the only thing that changes. I put camber. I didn't read it. I just got it by looking. I see it when he hits the bump. The top goes in a little bit on both sides. Camber. You now finished. Woo, that was easy. Independent suspension, easy. Maybe we can do one more. Let me do one more. One more for the road. One more. You know what? I'm not going to do another one now. Now you're free to go work on those modules. See if there's any of those that you didn't do. I did, what, 40 minutes, 41 minutes? You should be able to knock them out easy because I went over them with you, okay? All right. Hopefully Sue won today. I'm at a golf tournament, and I'll see you all tomorrow.